Good morning, students. Today's topic in physics, which we are going to read, is reflection. So, very important topic because it requires some kinds of practical questions and theoretical question as well. So, concentrate yourself. This is a tricky and technical topic. So, we are going to start now. The sun, lamps, lasers, and glowing TV screens all send out their own light. They are luminous. However, most objects are non-luminous. You see them only because daylight or other light bounces off them. They reflect light and some of it goes into your eyes. So these are two very important definitions. The objects which emit their own light are called luminous, and the objects which do not emit their own light but can be seen because of the light bounces off them are called non-luminous objects. Examples of the luminous are given: the sun, lamps, lasers, and glowing TV. The examples of the non-luminous can be in this room are, for example, walls, for example, tables, chairs, etc. because they can be seen only when some light from the other objects can bounces off them. Next topic which we are going to read in this lecture is laws of the reflection. The incident ray, the reflected ray, and the normal line are all in the same plane. This is the first law of the reflection. Here is the plane, here is the incident line, and here is the reflection line. So incident ray, the reflected ray, and the normal line are all in the same plane. This is the first law of reflection. The second law of the reflection is the angle of the incidence is equal to the angle of the reflection. So the angle between the incident ray and the normal is called angle of incidence, and the angle between the reflected ray and the normal is called angle of the reflection. So the second law of the reflection is the angle of the incidence is equal to the angle of the reflection. This angle will be equal to this angle. This is the second law of reflection. Water waves are reflected in the same way as light waves. Transparent materials like glass and water let light pass right through them. They transmit light. Important point for you is light ray hitting the reflecting surface is called the incident ray. Light ray reflected from the reflecting surface is called the reflected ray. The point on the reflecting surface where the light ray hits is the point of incidence. So this point is the point of incidence where the incident ray strikes. The perpendicular to the reflecting surface at the point of incidence is the normal. So from the figure we can see this is the normal to the reflecting surface where the incidence ray strike is called the normal. The angle between the incident ray and the normal is called the angle of incidence, represented by small I. The angle between the reflected ray and the normal is called the angle of reflection, represented by small r. Next topic which we are going to read in this lecture is the image in a plane mirror. So here is a plane mirror and you can see the reflection of the lighting candle into the mirror. When you look into a plain flat mirror, you can see a picture or image of yourself. The image is as far behind the mirror as the object is in front. So this is very important point. The distance between the real object and the mirror will be equal to the distance between the mirror and the image. These two distances will be equal. Next, this means that if the candle is 30 centimeter in front of the mirror, then the image is 30 centimeter behind the mirror. The diagram shows how the reflected rays appear to come from the image. So this is the diagram which is showing how the reflected rays appear to come from the image. The method to draw this image is, for example, object is here, image is here, and we want to draw the lines, reflected rays lines. So here is the eye lens. This is the upper point of the eye lens and this is the lower point of the eye lens. So this lens is actually will see the image of the object. So the method to draw the lines is join from the upper point to the image a line with the help of scale, and from the lower point of the lens to the image a line will be drawn. But the point to remember is from the eye lens to the mirror unbroken line will be drawn, and that line will be extended in the form of the broken lines. So after then, these 2 points, this is one point, this is the second, this point will be joined by the object with the help of scale. An unbroken line will be drawn, and likewise the second upper point will also be joined by the object with the help of scale by a unbroken line. So these are the reflected rays. Here is the top view of the glass, here is the object, here is the image. The line joining the object to the image is at right angles, 90 degrees to the mirror. The image formed by a plane mirror has the following characteristics. So this is a short question in this topic. The characteristics of the image formed by the plane mirror are: first characteristic is same size as the object. Second, literally inverted. Next is upright. Next is virtual. And next one is as far behind the mirror as the object is in front of the mirror. Important point is a virtual image is an image that cannot be projected or captured on a screen. It is produced by rays which seems to come from the image but do not actually pass through it. This is the definition of the virtual image. On the other hand, a real image, on the other hand, is an image that can be captured on a screen. For example, the pictures you see in a movie theater. The rays for real images you see come directly from the picture captured on the screen. Okay, next is very important topic in this lecture: how to locate the image of an object formed by a plane mirror. This is very frequent question which come in the paper. By drawing a ray diagram. So three-step method of drawing a ray diagram. Step 1, locate the image behind the mirror. equidistant and perpendicular to the mirror. Image size must be the same as the object. So if this is the object, we will draw an image of the same length and perpendicular to the mirror. And distance should also be the same. So here is the eye now, which will see the image into the mirror of the object. Now step 2. Join the image to the eye by two light rays. Virtual rays behind the mirror dotted line and real rays in front of the mirror solid lines. So now we will join the upper point of the eye lens with the object, with the image. But remember, up to the mirror, an unbroken line will be drawn, and behind the mirror, a broken line will be drawn. But this will be a straight line that will be drawn with the help of the scale. Likewise, the lower point of the eye lens will be joined by the same point, but in the same way, from here to here, an unbroken line will be there, and from here, this point to this point, a broken line will be there. But that will be a very straight line with the help of the scale. The third point, draw the incident rays by means of the reflected rays. Do not forget to draw the arrowheads on the solid lines to indicate the direction of the light rays. So the remaining method is now join this point with this point, because these lines are joined to this point, so its respective point is this one. So join this point with this point and this point with the same point. But remember, this is the actually portion in front of the mirror, so unbroken lines will be drawn. And finally, because light rays are coming from the object to the mirror and then reflected into the eye, so direction will be from here to here. Okay, next is image tricks. Magicians sometimes use images in their tricks. If you put your finger on the unlighted candle in this experiment, it looks as if your finger is burning. So the magicians use reflections. The reflection of the lighted candle can be seen into the mirror, and the magicians put their finger in the air that seems that their finger is into the flame and is burning. So this is the trick. Another trick is to fix the unlighted candle in a tall beaker, which you then fill with water so that it appears to burn underwater. So likewise, a lighted candle's image can be seen into the mirror, and then the magicians put a glass of the water that is empty in front of the mirror and put water into the glass, and it seems that candle is still lighting in the water. So this is the trick. Virtual images. If you go behind the mirror to look for the image, you cannot see it. This virtual image only appears to be behind the mirror. So, as in this case, a small child and a cat is trying to go behind the mirror to see their image, but there is no image. Only image can be seen into the mirror. This is virtual image, only appears to be behind the mirror. The image in a plane mirror is virtual and is the same size as the object. The image in a plane mirror is literally inverted. As you can see, the word ambulance is written in totally opposite direction. A is from here, then M, then B, then U, then L, then A, then N, then C, then E. But when you see the word ambulance into the front mirror of your car, you can see the word in the correct direction, in the right direction. So the image in a plane mirror is literally inverted. Next topic is the types of the reflection. There are two types of the reflection, namely regular or specular reflection and diffused or irregular reflection. So now we are going to read these two types of the reflection one by one. First is regular reflection. This is the figure of the regular reflection. Light is reflected in one direction only. So you can see light is reflected in one direction only. Occurs on smooth surfaces such as mirror or still clear water surface. So you can see here is a smooth surface which is reflecting the light in one direction only. Whereas the diffused reflection, light is reflected through a range of the different angles. So you can see this is a rough surface which is reflecting the light rays into different angles. So this is going here, this is going here, this is going there. So this is the first property of the diffused reflection. Light is reflected through a range of the different angles. Occurs on rough surfaces such as unpolished wall, paper screen, or cloth. Okay, next we are going to read some important applications of plane mirror. First application is periscope. Periscopes are used in submarines so that people below the surface can see what is happening above the surface. The diagram shows how light is reflected by the two mirrors. And here is a periscope. The mirrors are arranged in 45-degree angle. So light rays from the object hitting the surface and then perpendicularly fall on the second mirror, which is also on the 45-degree, and then perpendicularly gone to the eye of the observer. So this is the method how the persons into the submarine underwater can see the objects above of the surface. Remember that the angle of the incidence is equal to the angle of the reflection, and the rays should be turned through 90-degree each time. So this is 90-degree, this is 90-degree, and up to so on. Each mirror should be placed at an angle of 45-degree. Next application is building of periscope. You can use two handbag mirrors and a plastic bottle to build a periscope which you can use to see over people's head or to spy around corners. So take a transparent water bottle of mineral water, for example. Here are two mirrors, small mirrors, which should be placed at 45-degree. Here is the observer's eye. So when the light ray hit at the first mirror, it will go up to the 90-degree angle to the other mirror, and from there the light ray will go into the observer's eye. Next application is optical testing. The illuminated letters are literally inverted so that the patient can see the letters correctly in the mirror. At the same time, the letter appears further than they actually are, So the room need not to be that long. And here is the figure. For example, the illuminated box is just behind the patient, and patient is looking its image into the mirror. So whatever the distance of the illuminated box to the mirror, image will be formed at the same distance into the mirror. So this is the reason the letter appears further than the actual R, so that the room need not to be that long. And the another very important point is the letter written on the illuminated box are inverted, so that the patient can see them correctly into the mirror. Another application is blind corners. A plane mirror at a corner allows driver A to see driver B around a blind corner. So one driver is coming from here and second driver is coming from here. They cannot see directly to each other. But if here is a mirror placed that is at the 45-degree, the light rays will come from here and will fall perpendicularly to the driver 2, and so driver 2 can see the image of the driver 1 into the mirror. Likewise, driver 1 can see the image of the driver 2 into the mirror. So this is the way two drivers can see each other on a blind corner. Next is instrumental scales. By forming an image of the pointer, the plane mirror eliminates parallax error in the reading of the instrument scales. For example, on the speedometer of a car or bike, the reflection of the needle is formed. So, parallax error is removed, and driver can see very correctly what is the speed or the gauge of the petrol, etc. Other uses. Plane mirrors are also used in many optical instruments such as telescopes, overhead projectors, as well as lasers. And other common use of the plane mirror is in the construction of the kaleidoscope, which gives colorful multiple images of small pieces of the colored glass. So students, this was the lecture for today. Hopefully, you will understand it clearly. This will help you a lot. So read this lecture again and make your notes. Thank you so much.